Sir, when it comes to GPU workloads, is liquid cooling mandatory?
I think liquid cooling is not mandatory.
Why do you say so? And have you proved with air
Yes, we have
cooling is it
proved that
possible?
as long as your power envelope of a rack is less than 30 kilowatt, you can do with a combination of air cooling and indoor other cooling techniques, right? You don't need liquid cooling. Moment you cross 40 kilowatt, liquid cooling becomes mandatory.
So, does your femto address this particular question?
Femto is designed to work in an air cooled environment, right? So starting from 50 kilowatt, 500 watts to 5 kilowatt, you have different versions of femto, which can run with a low power envelope.
Welcome to second series of Mythbuster surrounding data centers. I am Vijayanand Gurudev. With me is CEO and co-founder of Vegan Labs, Mr. Srinivas Varadarajan. Welcome, sir.
Thank you.
Today we are going to discuss about, we will be focusing more on CPU, GPU intensive workloads, AI infrastructure, advanced cooling, and power optimization. So the first question is, more cooling always means better CPU or GPU performance. Your views on that, sir?
See, every CPU, GPU or chipset has an optimal temperature operating range, right? So you need to cool within that range. Let's say a GPU operates between, let's say, 50 to 60 degrees centigrade. You need to cool between that. If you undercool it, what happens? You are wasting energy. Okay, or if you allow the heat to increase, then what happens? The modern CPUs and GPUs have built-in thermal throttling mechanisms. So what happens if they overheat? They reduce the clock frequency, your performance goes down. So it's important that you cool it to the optimal range.
Okay. Sir, in the earlier session, we had spoken about heat isolation.
Yeah.
Like at the processor level, the heat isolation will be very high. So is GPU, when it reaches its thermal limit, will adding more fans help it, sir?
Again, see, the ideal way to take the heat out of is, from the chip itself, right? So basically, there are many technologies emerging today. One of them is liquid cooling, right? The cooling plates. So many research is going on. Traditionally, we use air cooling, right, to take the heat of the system. As we increase GPU densities, right, more and more silicon in a given area, it's important to take out the heat much more efficiently. So liquid cooling has proven to be one of the most efficient methods of taking heat out. There's also emerging technology, solid state cooling, right? Metal plates, solid state cooling, which can actually take the heat out.
Okay.
And this technology will continue to evolve, right? As we get, more and more compact GPUs, higher density CPUs, heat generation will be much higher, and this technology will continue to evolve, right?
Sir, we all know that training AI is much more costlier than inferencing it. So, will liquid cooling or air cooling is suggested?
So again, it depends on the density of heat, right? Let's look at a rack, right?
Yeah.
Up to 30 kVA of energy, energy consumption in a rack, you can use liquid cooling, air cooling to cool. Beyond 30 kVA, you need to use probably, heat exchangers to take the heat out.
Okay.
Maybe 30 to 40 kVA you can actually manage with heat exchangers and air cooling. Beyond that, I don't think this technique works. You need to probably use liquid cooling, right? It's the cooling distribution to take the heat directly from the chip outside. So today we are looking at rack densities of 60 kVA, 100 kVA. As the density increases, air cooling is not good enough, right?
It's not good enough. Okay. Sir, we always know that now taking example of a diesel engine.
Yeah.
Like when you run the truck at idle speed, meaning at 60 km per hour, and then you get better mileage.
Yeah.
Because the engine is also working at its optimum speed. Similarly, is there any optimum frequency or how CPU or GPU can be used? Is there anything that can be
I don't think there's anything like a vehicle is because the vehicle, the vehicle you have the constraints because there's a road, there's also air, right? Friction in the air is there. So there's a basically fluid dynamics involved there. But a CPU is just basically an optimal range, right? Operating range. Let's say the CPU maximum temperature is 65 degrees centigrade. Okay, let's assume. If you increase the temperature beyond 65, your performance goes down.
Okay.
Keep it below the, very low, right? You keep it, let's say 20 degrees centigrade, overcool it, you are wasting energy. So just keep the CPU operating range between the envelope, what the OEM says, right? Let's say Intel says your CPU max temperature is 65, 45 to 65 is the ideal range. You keep it with that.
Okay. So our IPM Plus helps in addressing this particular issue.
IPM Plus tries to do is to reduce the heat load on the chips, right? Basically, you use AI to predict the load.
Okay.
And when the load is low, right, you turn off the unwanted chips or reduce the frequency. You keep it, and again, that's one part, reduce the heat load.
Okay.
Second thing, to make sure that there's enough cooling, right? So you need a closed loop AI-based control system to understand the load of the CPU, the heat of the CPU,
Okay.
what's the amount of cooling required to take the heat out. So basically, it marries the heat load on the CPU with the chiller. Right?
With the chiller.
A
Okay.
closed loop AI system helps you to keep the optimal temperature on the CPU or the GPU.
So the workload and the chiller need to work in tandem.
Work in tandem, yes.
Okay.
And understand the workload is electronic.
Okay.
Chiller is a mechanical device. It's
So-
not easy to marry the both of them, right?
Okay. So and Vegan Labs has done this.
Yeah, yes.
So we have married the workload prediction with respect to chiller being
Chiller control system.
control
yeah.
systems.
Yeah.
Okay. Sir, can dynamic power capping really help?
It's sort of. So what happens? What is dynamic power capping? Let me correct. So basically, every rack, right? Traditionally, when you use a bus bar, right? Bus bar based, that's the design. You limit the amount of energy consumed per rack.
Okay.
Okay. And many times you actually, you under consume it because you feel. Let's say, assume I have, each server taking 2 kVA, 2 kVA.
Okay.
The maximum load on the MCB trips are 20 kVA.
20 kVA.
So I put 10 servers, assuming max 2 kVA into 10.
Okay.
Your ideal consumption could be
7 or 10 or 11.
1 kVA.
1 kVA.
So, but the server thermal rating is 2 kVA maximum load. You always put 10 servers and say my load is 20 kVA. So, it's because you have the unknown fear. Because any one server, of all the servers simultaneously, consume 2 kVA, it will exceed the load, right? It will trip.
It will trip.
So that's why you over provision the energy infrastructure in the rack.
So we
what
need
thermal capping does is that you statistically try to overuse, but at the same time cap.
Okay.
Let's assume instead of 10 servers, let's say I put 15 servers. Same time, it's possible I can't shut down servers. I put a thermal capping as server. Real time monitor the server energy consumption. Let's say it's 1.5 kilowatt. I make sure that the overall energy consumption in the rack does not exceed 20 kVA.
20
So I can do that. I can over provision
Okay.
more servers.
So you mean to say the intelligence from the MCB or the ACB should be transferred into the software?
Because the current MCBs are mechanical devices, right? The bus, see, there's a MCB is a bus bar. Bus bar and your wires have a limited capacity to carry current.
Yeah.
I can't expand, right? Capacity. The capacity is fixed. Electrical properties are limited.
And
so only way is to statistically look at
and
the
we don't have
load.
MCBs for lesser wattage.
Software you manage using software. Right? You just look at the load and you manage the load such that any server tries to consume more energy, you cap it, right? So the overall envelope is within the limits of the MCB.
Okay. There is always a myth saying that hotter GPUs always will fail. Is it true?
See, I think, once your GPU heat exceeds the thermal envelope, right? Let's say NVIDIA says, example, maximum limit is 85 degrees centigrade. If you exceed 85 degrees centigrade, GPU start throttling.
Throttling, yeah.
And if still the temperature goes, right, your silicon will start failing, right?
It start failing. Okay, we already answered the other question of inferencing versus training. So, can liquid cooling save energy?
Of course, what liquid cooling does, see, you are trying to take heat directly from chip, right? What does liquid cooling do? You are passing a refrigerant or a water, right, onto the chip directly.
Chip directly for heat transfer.
Basically, so air is not most efficient in taking heat out. But the low density is okay. As the density becomes higher, water or liquid is more efficient. You can take out the heat easily, quickly from the.
As we
chip.
know, the water can take out 27 times faster.
Water or liquid can take the, or use a liquid, which is actually probably liquid has a low thermal point, boiling point, takes the heat out, evaporates, and liquid condenses. So you recirculate the liquid, right? Just like today you have a car, right? Car engines have liquid coolant, right?
So we need to bring in the radiator system back into.
Sort of, simpler system here.
Okay.
Yeah.
So can AI cluster would they need identical cooling capacity? Because normally what we do, we try to concentrate all our AI workload into one rack. Or how do we address this in Vegan Labs?
See, basically, what we have done today is, we have designed over an AI servers, and of course, AI servers have a different thermal workload. So we need to isolate it. Typically, historically, data centers used to do was create a high density area, medium density area, and low density area. So high density could be 30 kVA and higher. Medium density could be 10 to 20 kVA. Low density is below 10 kVA. Because you can't change, So if let's say you have 10 racks, you can't have racks at one rack at 30 kVA, one rack at 10 kVA. Electrically, you can power them, but I can't, provide the cooling, right?
Cooling accordingly.
Because what happens, the 10 kVA rack will get overcooled.
Correct.
So that's why you need to isolate that. At the same time, make sure that you manage the heat, take the heat out more efficiently
More
in a
efficiently.
high density environment, right?
Sir, with our femto boxes in place, we have kept fans at both forward and at the backward position.
Yeah.
So, will the increasing the fan speed or guaranteeing that fans always work improve the performance of GPU? What is your observation?
See, one of the design principle behind femto was because there are a lot of data centers today, traditional data centers, which are air cooled, okay, or water cooled or air cooled, and there's enough space available. They're designed for 10 kVA, 15 kVA workloads. Can I put some AI infrastructure in the existing data center without rebuilding them, right? Because it takes time. And one is time, money and time also. Time is an important factor.
Correct.
Let's say my data center was designed with a 10 kVA per rack capacity. Let's say you want 30 kVA power. Building a new work, some place it may be possible to put a CDU and heat exchanger and make things work. Many data centers we found is difficult to change. It's a live operating data center, you can't change. So femto were designed with the need that can you make sure a GPU AI workload works in the existing data center, right? We may not be able to do so. We look at femto today. We have a different models have been designed with a fan. So we focus on cooling, right? Can existing data center with air cooled infrastructure can they handle that? So we make sure that there's enough airflow in the CPU. Take the heat out from the GPU and CPU optimally, efficiently. So that way, the servers can work with the existing data centers.
So, sir, now we are also running AI workloads in Vigan Labs.
Yeah.
And we are not consuming any water.
Yeah.
We are one of the few data centers who don't use water. And using only air, we are able to achieve this.
Yeah.
Your observations and your inputs on that.
Yeah. Because traditionally, data centers use water cooling, right? It's evaporating cooling, right? Evaporating cooling consumes about 2 liters of water for every kilowatt hour energy consumed.
Oh,
okay. So we always thought long before we build data centers that someday water is a precious commodity in places like India and many other parts of the world. What if you face water shortage? What do you do, right? And we wanted to create infrastructure which does not consume water. So from day one, we are clear that we'll use air cooling or probably liquid cooling. We'll never use water. So we have made sure that the traditional air cooled chillers are not very efficient. They consume a lot more energy. What we have done in Vigan Labs is, when we build data center, we have taken the air cooled chillers and built our own closed loop control system. So we are able to make the air cooled chillers as efficient or more efficient than a water cooled chiller. So that's the reason we are able to avoid water and keep the air cooled chillers as efficient as possible.
Okay. Sir, is underutilized GPUs, do they consume little power or do they keep working at the required power itself?
See, ultimately today's CPUs have basically the frequency. There's a F square is equal to power, right? Right. So basically, when GPUs automatically consume less power when under load conditions, right? But they still do consume some power under idle conditions.
Okay. Sir, we have this concept of server sizing.
Yeah.
Can I do GPU sizing? Just asking.
So we can do GPU. See, you need to look at the workload, right? What kind of workload are you running? What kind of models you are running, right? So basically, the workload, your models you are running, workload LLMs you are running. LLM decides your GPU size, right? Okay. LLM size your cache, right? Your KV cache decides your memory size. Let's say LLM model is a 40-bit model at 8-bit precision. You need 40 GB of RAM, VRAM for the loading the model, the weights, right? You need to load the model weights into the GPU memory. Plus, you need additional memory for other things, right? For operation need.
Okay.
So one is your model size decides one parameter. Second thing is throughput, right? How many tokens you want to serve?
Okay.
Can a single GPU serve? You need a cluster of GPUs, tokens per second, and context.
Okay.
Your context, model size, and throughput decides your GPU capacity, right?
But do we have that capability in the architects, in current days architects, who can do all this sizing and then come up with a appropriate GPU requirement? Because many a times we fail in doing this.
I think we need to spend, many times customer doesn't know because it's a new thing, right?
Correct.
So what I have seen at least in our experience has been working with a lot of customers, right? What kind of workloads people use, right? So there are use cases you can do a 12B model, 20B model, 70B model, 120B model. So with these models you can fairly, do most of the inference workload. Some rare cases exceptional, let's say 5% is 400B model, maybe 1% is trillion parameter model. So once you know the model sizes fairly well, you need to, then you can size fairly accurately, right? Yeah.
Okay. So what do you mean to say is people who develop applications over AI, they need to understand which model to choose.
Yeah.
And accordingly load the data set for that model.
I think the model itself will load data set. So
Correct.
what you need to know is which model you use for which use case, right?
Okay.
Yeah.
So not everybody needs LLMs. Even SLMs can do a good job.
Yes, fairly, yes.
Okay. Sir, we have spoken about power utilization. Can the higher utilization means energy efficiency will be low? Or how is this energy efficiency or PUE related to the GPU usage?
See as long as you have a proper closed loop control system, right?
Hmm.
I don't think the higher utilization and the lower utilization doesn't affect the PU much, right?
Okay. Sir, CPU undervolting, is there only for gaming PCs or can we do that in our servers?
Today, dynamic frequency scaling is a part of every CPU chip.
Okay.
So as a part of the IPM Plus, we do dynamic frequency scaling, right? So,
Okay.
so already all the
It's already there.
CPU, GPU providers provide you the capability to do that, right? Yeah.
Sir, some of the workloads, we know that these workloads will come at the end of the month or this comes every week, and but there are few workloads which come randomly.
Yeah.
So how do we as a data center handle these kind of random requests which peaks?
I think we need to look at the peaks. See, that's why you go to cloud, right? So you need to have extra spare capacity, right? You need to have
Okay.
extra spare capacity to take the workloads, right? So basically, it could be compute, could be memory, CPU,
storage,
IO, network. You need to have extra capacity. So the cloud works, right, today. So
the whole orchestration depends on the capability of running the cloud.
capability to spike up, take the spikes, right, and
Take the
and make sure that it works and
It works.
does not violate any SLA of the customer, right? Yeah.
Yeah. So cold aisle containment is one thing which we have observed in Vigyan Labs. How it is benefiting in operation?
See, basically, if you look at the rack, right, a rack takes about certain space, right? So when you do cold air containment, one of the things to use air efficiently, you just cool the area what requires to be cooled, right? You need to cool area. If you don't do cold air containment, so there are two ways of doing it. Either do hot air containment, contain the hot air, take the heat out quickly, or you do cold air containment, okay?
Okay.
So when you do cold air containment, you cool only the requisite area. The cold air is, concealed within the area. It doesn't escape, right?
Okay.
So the volume of cooling area is reduced. That's why you reduce the energy consumption of the.
Okay.
Yeah.
Okay, with this we come to the end of our second session on GPU, CPU power utilization. There are a few things. Software optimization, can it reduce data center power consumption as much as hardware upgrades is one thing which I want the viewers to have a look into it. Thank you.